Okay, so on these, we're going to determine if it's a function from looking at the graph. All right, so here we go. Remember, you cannot have any x's repeat. That's the whole idea of the functions. So any of these dots on this graph, what is my x dot right there? -2, comma 4, right? That would be my ordered pair. What is this x dot? If I go over here, my x is what? -1. If I go here, what's my x? 0. If I go here, what's my x? 1. If I go here, my x is like 1.5 or something. Am I ever going to find a spot on here where I can repeat an x? No. So the shortcut to this, remember I talked about vertical line? Anywhere you draw a vertical line, do you ever touch that function more than one time? No. Now look over here. Yes, if I draw a vertical line, I touch it twice. Right there, I have an ordered pair of 3, comma 1, and up here I have an ordered pair of 3, comma 4. See how those x's just repeated right there? See how I have an x and an x on the same spot? When I found a spot on this graph here and on this graph here that I would have the same x's. Are you allowed to have the same x, the same input? No. So right here, do you see how that vertical line test goes through it twice? So this one is not a function because we call that it doesn't pass the vertical line test. VLT, vertical line test. So that means I can have x's repeat on that. Okay? So go over here. Did this one pass the vertical line test? This is a function because passes the vertical line test. All right, anyone want to hear that explanation again? Okay, if you can find a spot on your graph that you have two different x's, or find two different spots where you have the same x, then you don't have a function. You are not allowed to have the same x. Is that the only spot I could have said was a problem on this circle graph? No, I could have gone anywhere that it has more than 2. What about that spot? Does that spot okay right there? Yeah, that's a spot that would have no problem. But these other ones with the same x, like that dot is 5, comma 1, and this dot's 5, comma 4, again, you have a repeat. That's how you know can't be a function. All right, what if I just have ordered pairs? So look at this, the non-continuous function. So you just want to see, do any of these x's repeat? Couldn't you list the ordered pairs if you wanted? Yeah, so this dot right here is -3, comma 2. Do I have any other x's that are -3? If you look at these dots? No. If you want, write them out so you can see. What's that dot right there? -1, comma what? -1, -1? Y'all awake? Okay. No. What's this x, or what's that ordered pair right there? 0, comma what? 4. And how about that dot? 2, comma 4. So look at my ordered pairs I wrote down. Do any x's repeat? No. So this is a function because no x's repeat. Okay, last one over here. Anybody see an issue on this one? Yeah, where? With what x? What number is it? 1. Everybody see x at 1? You have two different ordered pairs with 1, comma something and 1, comma something. So this is not a function because x's repeat. All right. Let's do one more thing on this graph. I wanted, with these two right here, let's try to list our domain and range from yesterday. Remember when we folded our flaps with domain and range? Okay, so this would be a good practice here. Y'all ready? So here's our parabola, and it has arrows. So put a D. This is something you have to know how to do. It'll be something you'll be tested on. We need the domain of this parabola right here. That's when you fold from side to side. So watch. If you fold this way, Are you going to have a starting or a stopping point?
No, because it's infinite.
Good. Arrows keep going and get wider as it goes forever and ever. Can you fold this way and have a stopping? No. Very good. So we call that all reals. Another way to write it is parenthesis negative infinity, comma, infinity. Do you guys remember that with interval notation? Okay. The only thing is you want to know both in case they ask for one versus the other. Okay, so write both of them down even if you have a preference of fancy R.
Wait, what does that say?
It says parenthesis negative infinity,
no.
comma. Domain is all real numbers, fancy R. Okay, how about a range? Range is when you fold from bottom and top. It has one. Is there one side or two side that you stop at? One, the bottom, right? So it has a lowest y. It has a minimum. What is it? 0. So how do you write that? All y's are what? Greater than or equal to 0. Good job. Y is greater than or equal to 0. Anybody remember how to write that in interval notation? Where does it start? 0. It starts only on the y. Just think the y numbers. It starts at 0, so we put bracket 0, and where does it go to? Infinity. So it would look like that in interval notation. Okay, let's do the circle real quick, and then we'll be done with this side. Okay, our domain for the circle. Domain for the circle. Fold left and right. Do you have a spot on both sides? And we're just going to approximate here. What do y'all think? Bless you. 2 to 6?
Yeah, 2.
Okay, 2 to 6. So we're going to write that down. 2 to 6. So you write 2 less than or equal to x, less than or equal to what? 6. Anybody remember how to write it in interval and bracket? This one's pretty easy. Where does it start? 2. So you put bracket 2, comma 6 bracket. Remember that now? Okay, I think that one's easier for that one. Okay, let's list the range. Can you start and stop from the top and the bottom? Yeah, where do you start? About 1. And where do you stop? 5. If you go this way, it would go to 5. So it's from 1 to 5. So we're going to write it the same way, except what's the letter in the middle now? Y. So 1 less than or equal to y less than or equal to 5, or bracket 1, comma 5 bracket. All right, cool. So that's that.